Hey guys, sorry about Tuesday missing our class, but I had to drive and move Meredith into her house for the next 2 years at school. Yay. Anyway, and I've been having some serious computer issues, so that's why I haven't been able to send the notes for this past Tuesday, so I do apologize. We'll get these going. They should be pretty much simple, straightforward, and we'll move on from there. So we have these notes and one more shot, and then we are done with notes. Yay! Very exciting. So hopefully everyone is doing well, and we'll move on. Make this kind of short and sweet. All right, so section 5.4, radical equations. All right, so now, again, let's see if we can get everything moving. Okay, so radical equation is an equation that has a variable under the radicand. Remember the radicand is that. All right. Now it doesn't have to be, remember this is the square root. It doesn't have to be the square root. It could be a cube root. It could be a fifth root. It doesn't make a difference. Okay. Next, steps for solving these. Get the radical alone on one side of the equation, just like when you're solving for a variable, right? If we had 2x, if we had 2, again, try this again. If we had 2x plus 1 equals 7, right, you would get that by itself. 2x by itself, okay? And then x by itself. So in order to get rid of a root, like how do you get rid of a square root? You square both sides. How do I get rid of a cube root? We cube both sides. So raise it to the same exponent, solve, and then the last piece of this is you have to check your answers. Okay, because under the radical can never be a negative number. I know we talked about i's, but in the scenario we're solving, so we can't have a negative number. Okay, so this whole first scenario, what I tell students if they're having a hard time thinking about this, if you look at it like this, you would know what to do, right? You would divide both sides by 2. Well, that's what we're going to do here. Okay, we're going to divide both sides by 2. And you're going to get the square root of x plus 2 equals 4. Okay, like I said, how do I get rid of the square root? I'm going to square both sides. Then when you square a square root, you are left with just whatever is left under the radical. 4 squared is 16, so x equals 14. Let me go back and check. 14 plus 2 is 16. The square root of 16 is 4. 2 times 4 is 8, so that works. Okay. All right, next one. Now we have a cube root. Same scenario. Add 2 to both sides. Sorry. 2x minus 5 equals 5. How do I get rid of a cube root? I cube everything. Sorry. Okay, so I'm left with 2x minus 5 equals 125. 2x equals 130. Sorry, x equals 65. That is my solution. Bring it back. 65 times 2 is 130. 130 minus 5 is 125. The cube root of 125 is 5. 5 minus 2 is 3. My answer works. Great. All right, moving right along. We have 3 more, and then you're done. Okay, this is a little different. I got variables on both sides. I'm going to still get this radical all by itself. So I'm going to get rid of the 5. X minus 5. Okay. And again, same scenario. I'm going to square both sides. And because you guys are so wicked smart, you're going to remember that x minus 5 squared is x minus 5 times x minus 5. Which gives me x squared minus 10x plus 25. Because then again, I know you're wicked smart, so this becomes x minus 3 equals that. Bring everything over to one side because we have a square now. Okay, remember when we did all the work with the quadratics, we want to bring everything over to one side. X squared minus 11x plus 28. Factor, I know your favorite. Minus 7 minus 4. So x equals 7 and 4. And again, remember what I said, you got to go back and check. Excuse me. So 7 minus 3 is 4. Square root of 4 is 2. 2 plus 5 is 7. 7 works. Okay? Now, we plug in 4. 4 minus 3 is 1. Okay? The square root of 1 is 1. 1 plus 5 is not 4. 4, if you remember that word, is extraneous. So x equals 7 is my only solution. Remember what happened, and this is where we have this extraneous piece. We altered the equation, we squared it, okay? When you alter it like that, you're creating, you only had a one linear function here, right? But we're creating a square, so we added something, that's why. Okay, we have radical. Again, it's nice because it's equal to 0. What I would do, I would put each radical on one side. So basically add the square root of 2x plus 7, square, square. This is a pretty simple, straightforward one. So x equals 5. 15 plus 2 is 17. 10 plus 7 is 17. Root 17 minus root 17 is 0, so my answer works. Okay, last one. Last one. It's a little bit hairy, but it's actually not so bad. Take a look. We have roots on both sides. It doesn't matter if I keep that -2 there or bring it over to a +2. It's not going to do anything. So I'm just going to sit here and I'm going to say, okay, you know what? I'm going to square both sides. Now, obviously, this left side is pretty simple. Okay. Now, what I'm going to do over here, help you remember, when you're squaring something, right, you're multiplying it by itself. So we're going to take this and multiply it with that. So square root of x plus 6 times itself is just x plus 6. This times -2 is -2 x plus 6. Okay. -2 times that, again, is -2 x plus 6. And our last one, -2 times -2 is a +4. Okay. So now I'm just going to combine my like terms. I got x plus 10 minus 4 x plus 6 equals x minus 2. I'm going to bring everything again. We're going to try to keep this radical. Okay, so I'm going to bring the x and the 10 over. -12. Okay, so now this will take us back to one of the first problems. So I want you to take this right here, and I want you to solve for it and get me an answer. And when we have class on Tuesday, we'll take a look and see how everyone did. All right. Hope you guys have a good weekend. And yeah, we'll see you Tuesday. Bye. Let me see if I can stop my sharing now. Sorry.